and then we proved that these, the left-hand side and the right-hand side are actually equal. So therefore the assumption, by proof by contradiction, the assumption that they're different, these are different, is false. And hence from that, therefore, this equals that. So they cannot, you can't have two of them that are the same. Alright? Alright, so they're all different. Now, let's try filling in the group table. So that's our group. We now have the members of the group, and they're all different. And A and B generate all of them, right? So A and B are the generators. You just see that just by looking, right? We've generated all 9 of them from A and B. So A and B are the generators, right? So let's try and find AB. Now, whatever value it has, because it's a group and closed, so AB has to be one of these 9, right? Because it's a group, it's closed. Now, similar to the analysis we had for G4, G6 and G8, you've seen it many times, AB cannot be any of these, right? Well, assume that AB does equal E. So therefore A is B inverse, but that means, but B inverse is B squared, because the order of B is 3, right? So therefore A equals B squared. So A is equal to B squared. That's not possible. They're different. We just proved they're different. So that doesn't work. So let A be A. Well, that implies B is E. B is E. That doesn't work, because we know they're different. And so on, right? You can go through it. So AB is A squared, so B is A, so B is A. But all these 9 are different, so contradiction. AB is B, therefore A is not, so A is E. So these two would be the same. That's not possible. AB is B squared, so B equals A, so B equals A. Again, contradiction. So ding, 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 ding. 1, 2, 3, 4. So we've eliminated 5 possibilities. We have an order of 9. We've eliminated 5. Okay, so that leaves 4 possibilities for the value of AB. 4 possibilities. So we have four cases. And what are those 4? What 4 have we not eliminated? This one, this one, this one, and this one. Okay, that one, that one, that one, and that one. So 4 cases. So let's consider those 4 cases one by one, and if we might be able to eliminate some of them, then we may get contradictions by assuming AB is one of these 4 values, one at a time. So so AB is either BA or BA squared or B squared A or B squared A squared, right? So let's do 4 cases. Case 1, 2, 3, 4. Okay, case 1. So AB is BA. That was our first one here. Well, that's for any AB. That means our group is abelian, right? It's an abelian group. And if you assume that, you now have enough information to write out your group table. That's easy to say. You'd have to actually get into the nitty-gritty and work and actually do it. But you'll find that that's true. So assuming this, you're able to write out your group table. So you can look at the result, and you will find, if you know enough group theory, that the result that you get is isomorphic to C3 times C3. Okay. So we have now found a second type of non-isomorphic group of order 9, and it's C3 times C3. It's a direct product of 2 smaller cyclic groups, C3 cross C3 times C3. So there's a second possibility. All right, now how about case 2? Remember that there were four of these, that one, that one, that one, and that one. That could be the value of AB. So, all right, let's try the second one. So AB is equal to the second one is BA. We've just done that one. So second possibility is AB is equal to BA squared. All right. Now, in fact, we'll show that that's impossible. Right. That leads to a contradiction. So, how to do that? Well, we will show that in fact the order, if that's true, then the order of AB is not 3. Now it has to be, right? All of these in this part of the analysis, well, except for the unit, of course, are all of order 3. So eight of them have order 3, because that's the assumption in this part. Of order 9 was here, but we've already covered that case. So they all have order 3. But here, if this equals this, if that's true, we will now show that the order of AB is not 3, and therefore contradiction. Alright, so let's go through with the analysis. So AB equals BA squared, that's the second possibility, this one. Okay. Now, the order of A, all of them, well except the unit, is order 3. So the inverse, A inverse is A squared, because A has order 3, right? So we've got that. So now let's find various powers of AB, and we will show that AB cubed is not E, right? Which it has to be. But if it's not, then you've got a contradiction. So let's work up AB squared, AB cubed, and so on, and eventually show that AB cubed is not equal to E. So then we've got a contradiction. All right. So what is AB squared? Well, it's just AB. But AB is BA inverse. So for here, plug in that, right? So you get BA inverse AB. The A's cancel. You're left with B squared, right? So AB squared is just B squared. Right, well what about AB cubed? Well, that's just the same thing as AB times AB squared, right? So that just goes unchanged. But AB squared here is B squared. So we just plug in B squared. So that gives us AB cubed. Now B is of order 3, so B cubed is just E, okay? So that you're just left with A. But that A is not E, right? These are all different, remember? A is not E. So the third power, if you like, the order of AB is not E. That's a contradiction, because we're assuming all these elements well, except the unit, of course. These other 8 are all of order 3, and we've got a contradiction. So that cannot be true. Right? So AB cannot be BA squared. So kill that one. Kill that possibility. That doesn't work. All right. Case 3. What's the third case? That AB might be equal to this one, B squared A. Right? Well, let's see what that happens. Now the inverse of B, because B has order 3, the inverse of B is B squared. Okay. So you can rewrite that as this. So again, we do the same kind of trick here. So AB squared is just AB. That carries over, no change. But AB now is B inverse A. So use this, plug it in here, so you get B inverse A. The B's cancel, you get A squared. Okay? So AB squared is A squared. Okay, now let's try the third power of this. So AB cubed is AB squared AB. Now what is AB squared? Well, it's A squared. So we can, instead of this, we just write A squared, AB. So that gives you A cubed B, but A cubed is E. A is of order 3, remember? So that's just B. But B is not E. B is distinct. We proved these are all different. B is not E. So B is not E, therefore the order of AB is not 3. Okay, so contradiction. So we can eliminate this one. That doesn't work. All right, try case. That's what these x's mean. It doesn't work. Contradiction. They're just cross. All right, case 4. So our fourth possibility, AB is B squared A squared. Here's our fourth, our third, second, and first. Now the only one that's worked so far was that one, the abelian case, when the group is abelian. All right, now try this fourth case. So AB now is B squared A squared. Now B squared is just the same thing as B inverse, A squared is the same thing as A inverse, because both A and B have order 3. All right? So AB squared is just AB, and that carries over. AB is B inverse A inverse, so put that here. The B's cancel, the A's cancel, you're just left with E. Ooh. Now that means that the order of AB is E. So, sorry. That means the order of AB is 2. Right? Smallest positive integer gives you the E, it's 2. But that doesn't work because AB, whatever it is, it must be one of these, right? AB has to be of order 3. But here we've shown that it's of order 2, if that's the case. Well, therefore that can't be true. So that kill that possibility. Well, that just leaves you with case 1 that worked, right? So summarizing now, how many different types of non-isomorphic groups are there of order 9? Well, we've got the cyclic group of order 9. That's always true for any n. For any order of a group, you always have the cyclic group, Cn, so Gn, the group of order n, is always isomorphic to Cn, the cyclic group of order n. Right? So that's one, this one, and you've got a second one here. So C3 times the direct product of two smaller cyclic groups, C3 by C3. Right? That's it. Only 2. Just 2 different possibilities. Okay. And now let's try G10. Much the same kind of analysis. So again, use the corollary that the order of the elements, except for the unit, is a factor, divides the order of the group. So what are the factors of 10 besides 1? Well, they're either 2, 5 or 10. Right? That's it. So our elements of this group, they must have an order of 1, 2, 5 or 10. They're the only possible factors of 10. Right? Well, forget about the 1 because that's just the unit as usual. So we have 2, 5 or 10. So again, let's go from largest to smallest. If one of the elements, one or more of the elements, has order 10, then that element is a generator of the group. Okay, so that means one of the group's isomorphic